Imagine living in a country where your home, your city, your airport, and even your future exist only because thousands of machines refuse to stop working. Now imagine that one powerful storm, lasting only a few hours, could erase centuries of human progress. This isn't science fiction. It's the reality of the Netherlands. Nearly one-third of the country lies below sea level. Millions of people live in places the ocean has been trying to reclaim for centuries. Yet despite facing one of the most dangerous coastlines in Europe, the Netherlands has become one of the safest countries on Earth. Not because the sea became weaker, but because Dutch engineers built something extraordinary. A flood defense system so advanced, it can predict storms, close giant sea barriers automatically, and protect millions of lives before disaster even begins. Many engineers call it the greatest flood protection system ever built. But it wasn't created overnight. It was forged through centuries of floods, engineering breakthroughs, and one catastrophic disaster that changed everything. This is the story of how the Netherlands built the world's strongest flood defense system. Water has always shaped the Netherlands. Long before modern cities appeared, much of the land was little more than marshes, tidal flats, and shallow coastal wetlands. The North Sea constantly pushed inland. Storms regularly flooded entire communities. People adapted the best they could. They built small dikes, raised villages on artificial hills, dug canals to drain water. Then came windmills, capable of pumping entire lakes dry. Over the centuries, these innovations transformed the Dutch landscape. But even the most advanced defenses had limits. By the 20th century, millions of people lived behind aging flood barriers. Ports expanded, cities grew, industry flourished. Yet much of the country's protection still depended on dikes built for another generation. Engineers knew improvements were needed. They simply didn't realize how urgent they had become. Then, during one winter night in 1953, the sea reminded the nation who was truly in control. On the evening of January 31st, 1953, a powerful North Sea storm combined with an unusually high spring tide. Ferocious winds pushed billions of tons of seawater toward the Dutch coastline. Water levels climbed far beyond what many flood defenses had ever experienced. One by one, the dikes began to fail. Small cracks became massive breaches. Within minutes, entire villages were overwhelmed. Seawater rushed across farmland, destroyed homes, and swallowed roads beneath freezing floodwater. Families escaped to rooftops. Some waded through the darkness, hoping rescue boats would arrive before the water rose any higher. Others never had that chance. By sunrise, more than 1,800 people had lost their lives. Tens of thousands were left homeless. Hundreds of thousands of acres of farmland were contaminated by salt water. The disaster shocked the world. But perhaps the greatest tragedy wasn't the storm itself. It was the realization that the country had trusted defenses no longer capable of protecting a modern nation. For Dutch engineers, this wasn't simply a flood. It was proof that the entire system had to change. Not next year, not next decade. Immediately, in the weeks following the disaster, the Dutch government assembled the nation's leading engineers, hydrologists, and coastal scientists. Their mission wasn't to rebuild what had failed. It was to ensure such a catastrophe could never happen again. The solution they proposed was unlike anything the world had ever seen. Instead of endlessly raising old dikes, they would redesign the country's entire southwestern coastline. Wide estuaries would be shortened. Massive storm barriers would replace vulnerable openings. New dams would permanently reduce the length of coastline exposed to the North Sea. Powerful pumping stations would become smarter, faster, and more reliable. Every major decision would be based on science, hydrology, and long-term climate planning. The project became known as the Delta Works. It would take decades to complete, cost billions of dollars, and forever change the relationship between humanity and the sea. But before a single barrier could be built, engineers first had to answer one impossible question. How do you build megastructures in the middle of an ocean that never stops moving? Building a bridge across a river is difficult. Building a tunnel beneath the sea is even harder. But constructing permanent barriers in one of Europe's most unpredictable coastlines was something engineers had never attempted before. The North Sea never stands still. Twice every day, powerful tides race through the Dutch estuaries. Strong currents constantly reshape the seabed. Winter storms generate waves capable of moving massive boulders. Every hour spent offshore, construction crews were battling nature itself. Traditional construction methods simply weren't enough. Dutch engineers developed entirely new technologies. Specialized dredging vessels reshaped the seabed before construction even began. Floating cranes lifted enormous concrete sections weighing thousands of tons. Custom-built positioning systems used lasers, hydraulic controls, and underwater surveying equipment to place structures with incredible precision. Some operations could only be performed during short periods of slack tide. Miss the window, and the entire installation had to wait for another tidal cycle. Each day became a carefully planned race against the sea. Millions of tons of rock, sand, and reinforced concrete were transported offshore. Slowly, the foundations of an engineering masterpiece began to emerge. But one estuary proved far more complicated than all the others. The Oosterschelde. Closing it completely would make the country safer, but it would also destroy one of Europe's most important marine ecosystems. For the first time, engineers weren't only fighting nature, they were trying to protect it. The original Delta plan called for sealing the Oosterschelde with a solid dam. From an engineering perspective, it was the simplest solution. A closed estuary would dramatically reduce the risk of flooding. But fishermen, marine biologists, and local communities strongly opposed the idea. The Oosterschelde wasn't just another body of water. It was a living ecosystem. Its daily tides carried nutrients that supported fish, shellfish, birds, and thousands of marine species. Blocking those tides forever would destroy an environment that had existed for centuries. After years of debate, Dutch engineers proposed something revolutionary. Instead of building a solid dam, they would create a movable storm surge barrier. During normal weather, the sea would continue flowing naturally through massive openings. The tides would remain. Marine life would survive. Fishing industries could continue operating. But whenever a dangerous storm approached, gigantic steel gates would close, temporarily transforming the open estuary into an enormous protective wall. No country had ever attempted a flood defense system on this scale. The project would become known as the Oosterscheldekering, and building it would require some of the largest concrete structures ever placed into the sea. Constructing the Oosterscheldekering wasn't like assembling a bridge. It was more like building a machine. Inside the ocean, the barrier would stretch nearly 9 kilometers across the estuary. Its backbone consisted of 65 enormous reinforced concrete piers. Each one weighed up to 18,000 tons. Between them hung 62 massive steel gates, designed to remain open most of the year. Every pier was built inside massive dry docks on land. When complete, they were floated into the North Sea using specially designed transport systems. Then came the most difficult part, positioning each structure with centimeter-level accuracy. Powerful currents constantly pushed against the floating giants. Even a slight misalignment could prevent the gates from operating safely. Engineers relied on computer-controlled hydraulic systems, precision surveying equipment, and specially designed installation vessels to lower each pier onto prepared foundations. One by one, the massive structures disappeared beneath the waves, locking perfectly into place. When the final gate was installed, the Oosterscheldekering became far more than another flood barrier. It became proof that engineering could protect both people and nature without sacrificing either. By the late 20th century, much of the Netherlands was protected, but one critical weakness remained: the port of Rotterdam, Europe's largest seaport. Every year, more than 400 million tons of cargo pass through its terminals. Thousands of container ships, oil tankers, and bulk carriers depend on its waterways. Closing the river permanently with a dam wasn't an option. It would paralyze one of the world's most important trade hubs. Yet leaving the waterway open exposed millions of people to the threat of a catastrophic storm surge. Dutch engineers faced a challenge unlike any before. How do you stop the sea without stopping global commerce? Their answer became one of the most extraordinary moving structures ever built: the Maeslant Storm Surge Barrier. Instead of a fixed wall, engineers designed two gigantic floating steel gates. Each arm measures approximately 210 meters long, longer than 2 football fields placed end to end. Most of the year, the gates rest inside enormous dry docks beside the river. Ships pass freely between them. The barrier is almost invisible to everyday life. But when a dangerous storm approaches, the entire structure awakens. The arms slowly rotate toward the center of the waterway. Massive ballast tanks fill with water. The floating gates sink onto the riverbed. Within just a few hours, one of Europe's busiest shipping channels becomes a solid defensive wall against the North Sea. It isn't simply a barrier. It's a machine, designed to protect an entire nation. The Delta Works isn't controlled by workers watching the horizon. It relies on something far more powerful: information. Across the Dutch coastline, thousands of sensors continuously monitor the environment. Sea level, wind speed, atmospheric pressure, wave height, river discharge, rainfall, groundwater conditions. Every second, new information flows into advanced monitoring centers. Powerful computer models compare real-time conditions with decades of historical data, live weather forecasts, and tidal simulations. When an approaching storm threatens the coastline, the system begins calculating exactly how high the water could rise. If that prediction exceeds the safety threshold, the closure process begins automatically. Operators continue monitoring every step, but computers make critical decisions long before humans could react. For barriers like the Maeslant, precision is everything. Closing too early could disrupt global shipping. Closing too late could place millions of lives at risk. Every movement is carefully calculated. Every sensor has backups. Every critical system is continuously tested, because during an extreme storm, there is no room for error. Unlike a bridge or a skyscraper, the Delta Works is never truly finished. Every day, engineers inspect barriers, monitor dikes, test hydraulic systems, and analyze new environmental data. Autonomous underwater robots examine foundations hidden beneath the sea. Drones scan concrete structures for microscopic cracks. Satellites measure tiny movements in the Earth's surface. Artificial intelligence helps predict future maintenance needs before problems become visible. Pumping stations quietly move millions of cubic meters of water every day. Backup generators stand ready in case of power failures. Emergency control centers operate around the clock. Even during calm weather, the entire system remains on alert, because the Dutch understand something few nations have experienced. Flood protection isn't a project you complete. It's a responsibility you maintain. Every hour, every day, for every generation. The sea never takes a day off. Neither do the people protecting the Netherlands. When the Delta Works was completed, many believed the Netherlands had finally defeated the sea. But the engineers who designed it never made that claim, because they understood one important truth: the ocean never stops changing. Today, global sea levels are rising. Warmer oceans are expanding. Melting glaciers are adding billions of tons of water every year. At the same time, storms are becoming more unpredictable. Extreme rainfall is increasing the pressure on rivers, while higher tides place even greater stress on coastal defenses. For most countries, these changes represent a future problem. For the Netherlands, they are today's reality. That's why the Delta Works is constantly evolving. Storm barriers receive new sensors, new software, and upgraded hydraulic systems. Dikes are strengthened. Pumping stations become more efficient. Computer models are continuously updated using satellite observations, climate simulations, and decades of engineering data. The goal isn't simply to react to the next flood. It's to prepare for storms that haven't happened yet. Because protecting the future requires planning decades ahead. Not days, not months, but generations. The Delta Works was built to protect one nation, but its influence quickly spread across the world. As coastal cities faced rising seas, governments began asking the same question: how do you protect millions of people without stopping economic growth? Many found their answers in the Netherlands. Dutch engineers have advised flood protection projects in the United States, the United Kingdom, South Korea, Vietnam, Indonesia, Bangladesh, and the Middle East. After Hurricane Katrina devastated New Orleans, Dutch water experts helped shape new flood protection strategies. Cities like London strengthened their own storm surge defenses. Venice introduced movable flood barriers inspired by similar engineering principles. Even countries that look completely different from the Netherlands continue studying Dutch water management, because while coastlines may change, the science of controlling water remains universal. The Delta Works proved something remarkable. Flood protection isn't just about building higher walls. It's about combining engineering, technology, environmental science, and long-term planning into one intelligent system. Today, that philosophy is becoming the global standard. For thousands of years, civilizations accepted floods as unavoidable. Storms destroyed cities. Rivers changed course. The sea always took back what it wanted. The Dutch refused to accept that future. Instead of retreating, they engineered a new reality. The Delta Works isn't simply a collection of dams, or steel gates, or pumping stations. It's one interconnected system where thousands of machines, millions of sensors, and decades of scientific knowledge work together every second of every day. Most people living behind these barriers rarely think about them. Children go to school. Cargo ships enter Rotterdam. Farmers harvest their fields. Families sleep peacefully through winter storms. Not because the sea has disappeared, but because one of the most advanced engineering systems ever created stands silently between civilization and the ocean. The Netherlands didn't build the world's strongest flood defense system because it wanted to. It built it because survival demanded it. And perhaps that's the greatest lesson this remarkable country offers the world. The future isn't secured by hoping disasters never come. It's secured by preparing for them long before they arrive. Because the greatest engineering achievement isn't defeating nature. It's understanding it, adapting to it, and building a future strong enough to stand beside it. Every storm that passes, every barrier that closes, every city that remains dry, is proof of one extraordinary idea. Humanity may never control the sea, but with enough knowledge, enough determination, and enough engineering, it can learn to live safely beside it.